Dynamic routing protocol. See, whatever the price may be for a router, the routes cannot be magically shown out in the routing table. Not possible for a routing table to show the routes just like that. The configuration need to be done. We need to write either static route or we have to enable dynamic routing protocol. So we got 3 routers and see there's an interface called loopback interface. It is not a physical interface. The purpose of this address, the interface, is to assign an address and get a network so that we can have a network. See, I want to show there is a network. Usually we used to have a physical interface to put an IP address and that will appear as a network in the routing table. But instead of connecting a physical link, you can create a virtual link, assign an IP address and get the network. The purpose is I just want to have some networks without having any physical setup. See, loopback interface has got different purpose, different with different protocol. For example, if I enable multicasting or MPLS, they are going to use loopback interface as the ID of the device. But in our current topic, this is the reason why I'm going to have a loopback interface. I want to have a network. But I do not want to spend a physical interface or a physical port. If I don't have loopback interface, see this thing you have to learn it now itself. Later you will never learn about this. So if I don't have a loopback interface, I have to connect a physical wire. I need to connect a switch. I may need to connect some computers. Only then this port will be up. I have a physical port. I said no shutdown. I gave IP address. Will I be able to ping? Not possible. Even though I said no shutdown, because there is no wire connected, this address cannot be reached from anywhere because there is no wire connected. Operationally it will be down. Protocol will be down. Line protocol will be down. Physically it is up. Administratively it is up. So even if I have a computer, because the computer is off, this address cannot be pinged from remote. This won't be active at all. But I don't have any of those problems if I have a loopback interface. I no need to connect a physical wire or a switch and the PCs. Nothing. I just go and create a virtual port called loop back, and this virtual port can be identified with a number between 1 to a very big number. So if I want to identify the loopback interface with the year of my birth, I can match 2022. See, I can give the ID as 2022 for the loopback interface. Yeah, that's what I want to say. There's no small number, big number. You can have any number that you like. I'll show you the limit, but that limit itself is too much. That is not a limit. I'll show you while I configure. What I mean to say is you can give any number to identify this loopback interface. Any number. But usually I give 0. Loopback 0. Then immediately the interface gets created. When I say interface loopback 0, only then it gets created because of this command. Because we create this, you no need to say no shutdown for this interface. Because it is the one we created it. It will be up by default. But on the physical interface, you have to say no shutdown to bring it up. Now I'm going to give an IP as 1.1.1/32. You know why 32? I'm masking it fully because I don't want any other address. Because it's a virtual interface. See, only when I have a physical interface, I'll have a physical wire, and that physical wire will connect to some computers to which I need to give IP address from the same subnet. We don't have physical link here. See, only when I have a physical port and connect a physical wire, I need more than one IP address. One IP address on this interface, one IP address on this, and if I connect a switch and connect more computers, then more IP addresses. When I have a loopback interface, there is no need for IP address except this IP that we give on this loopback interface. Because you cannot, it can be even /8, it can be even 16, 24 or 25, but this will make more sense if you make it as 32. Why? If I put /24, then I have a range of IP address, but where will you use? It's not a physical port. We are wasting. So you will see OSPF, a routing protocol called OSPF. Even when I make mistake like /24, it will say OSPF will say no. I'll advertise it as 32 because you are giving it from loopback interface. OSPF, when it distributes to the neighbor, it will distribute a /32, not a /24. But I might have configured a /24. But OSPF is smart saying, no, you see, I'll advertise it as /32 because the interface type from where I'm copying this address is loopback. Anyway, when we go OSPF, I'll show you that now. I have created a loopback interface and I have put an IP address. The reason why I created loopback interface is I want to just have a network. And unrouted to. I got 2.2.2.2 And router 3. See, loopback we draw a little bit, bend line like this. So don't think, I'm just drawing like that. That's the usual way of drawing loopback. If I want another loopback, I'll draw like this. A bend line, not straight line. Okay, these are the loopback interfaces of 3 router and the IP addresses. Now between R1 and R2, let's say we got 10.12.0.0/16. This is the network between these two. And I'm going to give .1 in this port and .2 in this port. Which means what? 10.12.0.1. So instead of writing this big number, I'm just writing the network here, .1. Network here, .2. Likewise here, 10.23.0.0/16. .2, .3. Right. If we have something like this, we need either static route or default route with static route or a routing protocol. Cheaper router or costly router, every router needs your help. They cannot discover without a protocol. We need to enable protocol. If you need dynamic routing protocol, you need to enable it. Dynamic routing protocols will write the routes into the routing table by discovering the networks of the other routers, remote networks. How is this possible? Through advertisement. Advertisement makes these routers to learn others' network. For example, router 3 will advertise saying, I got 3.3.3.3/32. And router 2 will learn it. Now router 2 will advertise saying, I got 2.2.2.2. I also got 3.3.3.3, which I learned. I also got 10.23.0.0/16. And router 1 will now learn about those networks. So, they all talk each other. So advertisement makes other router to learn about this router. So this router advertises whatever it has got. That's all. Likewise, the other router advertises whatever that has got, and this router will learn it. Through advertisements, we call this route updates. Advertisements are called as route updates. For our understanding, I said advertisement. Route updates. Route updates are sent. You see, when router 2 advertises to router 1, it is not only advertising to and 10.23. It will also advertise 3.3.3.3, which it learned. So the route updates are not only of that router, it is also those that are learned. Router 3 advertises, router 2 learns. After router 2 learns, it advertises. So along with its own, even the learned routes gets advertised. So now router 1 gets chance to learn all the networks. Likewise, router 1 advertises, router 2 learns, router 2 advertises, router 3 learns both router 1's network and router 2's network. So now they're all in sync. If any user pings any of this network, the routers are capable of forwarding it because they got the route. So routing protocols discover the route dynamically. That's why it is dynamic routing protocol. And this discovery is via route updates. We are going to see different protocol, different routing protocol. Every routing protocol has got its own style of sending route update. Yeah. Very nice. Good question. So someone want to give you a gift. You were thinking that only one person is going to give you a gift, but two people came with two similar gift. One with the BMW, one with the old Ambassador Nova. Which one you will take? Both are car. Both can take you to anywhere wherever you want. Of course, I will take BMW. Yeah. So, but there will be some old people who like Ambassador very much. They will take Ambassador. So it is all dependent on the router. There is something called administrative distance. That's why I took two different people, old people, youngsters. This generation will take BMW or Hummer kind of. Some old people take Hummer. Anyway, I'll take BMW, not the Hummer or Ambassador. But my grandfathers will take Ambassador. Likewise, Juniper, Cisco, Huawei. There are various vendors. One is grandfather, one is teenager, one is adult. What I'm coming to say is you cannot expect all vendor to take same decision. Every vendor has got their own prioritization, preference. That preference is what we call as administrative distance. In Cisco, smaller the administrative distance value, high weightage. Let me repeat. Question was this. I have two protocol. Let's say one is OSPF, another one is EIGRP. Both the routing protocols are giving routes. Both the routing protocols give routes to reach a particular destination. For example, to go to a railway station, this router says, R11 says, you should go this way because OSPF given route is this way. And same router will say, no, EIGRP is told to go this way. If both the roots are there in the routing table, confusion. So now the router will decide. If it is Cisco router, it it will choose this as the path and ignore this. This path will not be seen in the routing table at all. It won't be seen. If it is some other vendor, they will ignore this and prefer this. You know why? Because EIGRP Cisco proprietary, Cisco only will prefer that. Rest all will prefer OSPF. Now, in Cisco router, to make EIGRP as highly preferred protocol, a number 90 as administrative distance is given, whereas for OSPF it is 110. Repeating again. ஐயா ரயில்வே ஸ்டேஷனுக்கு எப்படி போறது? லெஃப்ட்ல போப்பா. அம்மா ரயில்வே ஸ்டேஷன் எப்படி போறது? ரைட்ல போப்பா. So two people have given two different directions, left and right. Which one will I take? இந்த அம்மாவை பார்த்தா லோக்கல் மாதிரி இருக்குது, அந்த ஐயாவை பார்த்தா அவரே ஊரை விட்டு ஊர் வந்த மாதிரி இருக்குது. Let me follow this அம்மா's direction. சரி, when I follow the அம்மா's direction, I go to the destination. அம்மான்னு சொல்றதோட கஷ்டமா இருக்கு இந்த இந்தியாவில். அந்த அம்மா போயிடுச்சு, இருந்தாலும் இம்பேக்ட் இருக்கு இன்னும். So we choose to go via the path because of the trust level that you keep on that Amma more than that Ayya, because that Ayya looks outsider. The Amma looks local. So she may give better path. The trust level, the administrative distance, smaller the trust level, because it is given in numerical number. Smaller means more trust. EIGRP routing protocol given routes are more preferred than OSPF given routes. See, this router knows both the routes, but in the routing table, that is what in the previous class I was telling you. The decision maker is not routing protocol. Routing protocol will only prescribe routes, suggest routes. It is the RIB process, routing information base, which is going to do these things like comparing the administrative distance. Who is telling this? That is what administrative distance. RIB will check who is giving me this info. If two people are giving a path for giving different path for same destination, I cannot consider both. I have to pick one and ignore the other one. Based on what? Based on who gives it. If it is given by EIGRP, I am more glad to use EIGRP than OSPF because my router is a Cisco router. Cisco router wants to prefer Cisco's protocol. So, to an extent, I have explained you administrative distance. I'll repeat again later. This was not a topic in today's class. I just answered. Now, we got networks. Router 1 will not know about 3333 nor 2222 nor 10.23 because they are not connected directly. I need a routing protocol to make it learned, make those networks learned dynamically into the routing table. If I need to learn dynamically into the routing table, I need a routing protocol. How is this going to work? Through route updates. In a simple term, advertisement. Okay, we're going to advertise. I also told you we have different routing protocol, but routing protocol is to discover route. Then why we need different protocol? Why we need more than one routing protocol? So every protocol has got its own style in learning routes, in sending updates, in the way that they converge when there is a change. Everything, there's a uniqueness for every routing protocol. Like every person is different, right? Routing protocol is also different. Each routing protocol has got its own way of advertising, way of converging to the network change, much more. So, whichever suits our expectation, we'll pick that routing protocol. We'll enable that routing protocol. We got many routing protocols. Whichever is good for you, your expectation, you can go with that. That's why we learn different routing protocols. The first routing protocol that I would like to teach is OSPF, Open Shortest Path First. Usually, there is a protocol called Routing Information Protocol. Everyone will teach, and even I used to teach that. But from this batch onwards, I'm trying to make a difference. Let's learn which is most important first. And then we'll go to the simple protocols like RIP, Routing Information Protocol. Now, what is this OSPF stands for? It stands for Open Shortest Path First. Open Shortest Path First. Open Shortest Path First. You see, this word is not a new word for you if you are from physics or computer science or mathematics background. Shortest path first. Shortest path first is a binary tree algorithm, which we might have learned in college days. I learned this in 2003 in my master's degree, computer science. Shortest path first. So, of course, now also it is there in syllabus. Shortest path first. Binary tree algorithm is another word. There are many names for this. Dijkstra's algorithm is also one of the names. Dijkstra's algorithm. The algorithm was proposed by a person called Dijkstra. So his name is given, Dijkstra's algorithm, not given by him. People have given the name as Dijkstra's algorithm. This algorithm is open standard. SPF is open standard. So this SPF algorithm, Dijkstra's algorithm, is used everywhere, even in Microsoft operating system, uh, microprocessors. The way that they choose the data from the storage. They all use this SPF algorithm. And that same algorithm is now also used in the routing protocol to discover the best path. Wherever you want shortest, you can use this path. Whether it is in a microprocessor or the operating system locating a file from the disk, or in the network finding the location of a remote network, or in the network finding the location of a remote destination. In all these places, we look for a shortest path. So this is the best algorithm, SPF. So using this SPF algorithm, the routing protocol is designed. And that routing protocol is what opens shortest path first. This is the algorithm name. But with that algorithm, you cannot do anything. You need to develop a protocol. For finding the destination, they have developed this protocol called OSPF. Again, this is also an open standard routing protocol. SPF is also open standard algorithm. This routing protocol OSPF is also an open standard protocol. What does that mean? There is no ownership. There is no proprietary. Anyone can use this protocol. It's industry standard. If it is Cisco's, then you need to ask Cisco permission to use in your device. If you are not Cisco. But for OSPF, you no need to ask anyone. If you are a designer if you design a router, you can have OSPF. It's an open standard protocol. It's an open standard routing protocol. What it will do, routing protocol will advertise the routes, send the route updates, which will make the other routers to learn this router's network. So learning of routes, dynamic learning of route is what this OSPF is going to do. So this is what the topic that we will have as the first topic. And then we will get into another another industry standard protocol, open standard protocol called RIP. For this also, you don't need to take anyone's permission. Industry standard protocol. Routing information protocol. Now this is also an important protocol. Depending on where we use. RIP or SPF, according to me, all are important. Some may say RIP is not that important, cannot support large network, all the stories. See, if you want large network with routing protocol, then go with OSPF. But when we know how RIP protocol works, that uniqueness in the RIP may be needed in some places. There you will enable RIP. OSPF cannot be best there. Even though OSPF is considered as the best protocol now, the reason is the environment that most of us have got is big. So you say OSPF. There may be some places where RIP is the best protocol, even in that big environment. There will be one corner of the network where you want to take path selection like what the RIP protocol will do in RIP style. There OSPF will not fit in, only RIP. Yeah, even if you have BMW car, if you go to a village, you have to leave it outside the village because there is no road. Only Verap மேல தான் நடந்து போகணும். So your leg is not that cheaper. Your leg is God given vehicle to move. RIP is like that. Though we don't walk too much nowadays, we always depend on vehicles like OSPF. There are some situations where you have to use your leg to walk. RIP is also a very important routing protocol, according to me. That is why you need different protocol. We will pick one which suits that environment. RIP is also a routing protocol which is used in a certain situation. That's why we learn all these things. See, only when you learn all these protocols in depth, you will know which routing protocol where to put. Otherwise, this is also another routing protocol. You can use that or this. That is better, That is better. OSPF is better. It will have a lot of outcomes, a lot of stories that people will say. It is all lack of knowledge, I tell you. If someone says OSPF is the best, RIP who uses? They have some knowledge limitation. That's why they speak like that. We have all these protocols so that you can use the best one according to the need. Every protocol is best in its own place. You cannot replace with other protocol. Yeah, if you replace it will work, but it won't give you that satisfactory output. Another protocol is EIGRP. What are the advantages of RIP? Because I have not delivered RIP, I should not answer this, but only for your question I am answering it. RIP decides the best path based on what? Hop counts. Correct? Now, when I have tunnels, tell me, going through tunnel will be less hop or going through the physical path will be less hop? See? If I want my path to be via tunnel, why did I configure tunnel in first place? I want to use the tunnel. But if you put OSPF, it will compare the cost and it will go via the physical link, not via the tunnel. OSPF will say more the bandwidth, better is the route. I'll go via the physical link because tunnel is too narrow. Tunnel is using the physical link, so definitely tunnel bandwidth will be lower than the physical. So all traffic will go via physical link, it will not use tunnel. But when I put RIP, automatically it will go via tunnel. I no need to tell the traffic to go via tunnel. When I put RIP, automatically traffic will go through the tunnel because hop count via tunnel is less. You understood? Very good. Enhanced interior gateway routing protocol. This is another protocol. Alright, so we have a lot of protocols like this, but popular ones are OSPF, RIP, EIGRP, ISIS, and BGP. ISIS and BGP. Okay, BGP I'll teach you to an introduction level because it's CCNA. I cannot go deep into it, but we'll go in depth on BGP when you come to next level. Even OSPF, RIP, all this RIP will complete in this training, but EIGRP and OSPF in depth will come in the next level. But to an extent, I'll do some justification. I'll give the best in this itself. Yeah, we will have both in CCNA, CCNP, and CCI, all levels. We'll have this protocol repeated. But RIP will not come in NP, but it will come in IE. I again. After NA, it will come in I. But it's going to be the same. So I'll cover the RIP completely here. EIGRP to an extent, OSPF to an extent. Also, I'll give you some good introduction to BGP. So this is the order in which we are going to go. Our first protocol will be Open Shortest Path First, whose administrative distance is 110, according to Cisco. So this number will not be same for other vendors. For Cisco, this is the number to prefer OSPF. Smaller the number, more preference. Repeating again, the number should be small to get preferred by the router, OSPF router. For RIP, if you see 120. For EIGRP, it is 190. You see, when you have all these three protocol on a router, on a Cisco router, EIGRP's recommendation, EIGRP's path recommendation is what going to be preferred. EIGRP's path recommendation is what going to be preferred because the administrative distance smaller is highly preferred. 90, of course, it is smaller than 110, and 110 is smaller than 120. So high weightage by Cisco router is given to EIGRP, next to OSPF, next it's given to RIP. So with this number, you should not judge. With this number, you should not judge saying, see, number is 120. RIP is less preferred, you see. No. See, this is dynamic routing protocol. If numbers are same, then router will be in confusion. So some decision router has to take dynamically. That is why they have put this number. This is not the number with which you need to say this is important and that is less important. You know one thing, you can change these numbers. The default is this. You can change RIP number as 10 and OSPF number as 200 and the EIGRP number is 150. You can change. Now RIP is more preferred because it is only 10. So this is just for default. They have put this number. Based on this number, don't judge. Every protocol is important. I already gave a very good example for Abhi's question. That's the best example why RIP is more important. So most of the situation, OSPF suits, so it has got popularity. It has gained the attention. It doesn't mean that other protocols are useless. That's the point that I'm emphasizing here again. We learn all this so that whichever suits our environment, we should put. Not because everyone uses OSPF, I'll use OSPF. And in my environment, maybe RIP is better than OSPF. Right. The other differences is the convergence, the timers. Of course, yes, RIP is comparatively slower in convergence. What does that mean? Comparatively slower in convergence. What is convergence? Adapting to the network change is what called as convergence. When a change happens, how quickly this protocol can update the changes. RIP is slower. In convergence. But we cannot say RIP is slower comparatively. EIGRP is also slower compared to OSPF. OSPF can converge very fast seamlessly because of the database that they maintain, which we will not be talking now later. Those are in depth. Fine. So we are going to learn these protocols, especially OSPF, RIP, and EIGRP. OSPF with single area, not multi-area. Multi-area we learn in CNP. RIP incomplete and EIGRP basic, not advanced EIGRP, basic. Right. So tomorrow we're going to start with OSPF, Open Shortest Path first. Any question on today's class? Welcome. Thank you. Right.